Anytime you have a job shop that consists of two processes, like first this has to be done, then that has to be done for each job, that situation, that scenario is just crying for Johnson's rule. This bakery that's featured in this problem is a classic example of that. Let's take a look. All work orders at the bakery require prep and then baking. That is telling you this is a Johnson's rule problem, because it's saying that everybody has to go here first for a certain amount of work and then here. It's that two-step structure that tells you it's Johnson's rule. All right, now what's the actual question? In order for a single birthday cake requires the least amount of baking of all orders of the day. So it's going to spend the least amount of time here. Assuming that the bakery wishes to minimize the make span. What is the beauty of using this technique that's known as Johnson's rule? It minimizes the make span of a schedule. Anytime you're trying to get work to flow through two steps, it figures out the one way to get it all through the quickest. Now, what is it asking? When should the birthday cake be scheduled? Which is to say, what exactly is Johnson's rule? Johnson's rule is that technique where you look at all the data, how long different jobs need in prep and how long different jobs need for baking, and you're always looking for the smallest number. What's the absolute smallest amount? If it occurs in prep, you say, schedule that job as soon as possible. Schedule that job at the front of the sequence. Start on that job as soon as possible. If it occurs in baking or the second process, schedule that job as late as possible. Schedule that job at the back or as far to the back as possible. Now, this question isn't telling you about all the different jobs. It just says about this one birthday cake. There's something specific about it, and it requires the least amount of baking, the absolute smallest amount of time. That means that since that's the second work center, if it was selected for that, the answer is you would want to schedule it last. The least amount of baking means, we didn't need to know what the actual number was. It's the smallest. That's the second work center. It goes to the back. Now, there is one naive assumption with this particular problem, and that's that we're scheduling it because of that number. That was the number that caught our attention, baking. Well, we would be scheduling it because of that number for a fact, as long as however long this birthday cake needs for prep is a larger number, because we always are fascinated with the smaller number. It doesn't actually say that. So it's possible that we'd select it for the other number, and I mean that would be kind of rare, but you could cook up a situation that way, which is why actually, truthfully, if you want to cover every possible thing that could happen with a birthday cake, we kind of weaken a little bit and we say, well, it would probably be scheduled last. At least that's the principle of Johnson's rule. Now, similarly, look at the next question, because it's basically about the same situation, right? All work orders at a bakery require prep and then baking. Okay, this is the same bakery. It's the same bakery, it's just asking about a different order. What's it talking about here? A batch for baked apples requires the, let me mark on this a little bit, least amount of prep of all orders for the day. Okay, so there's this other order for baked apples, and we're saying what catches our attention about it is it possesses the absolute smallest number for the first process, right? When should it be scheduled? This is still a Johnson's rule situation, except that if the smallest number that caught your attention occurs at the first workstation, you would want to schedule that job first. Okay. Although this question has that same little funny detail like the last one, in that especially, that would always happen as long as the baking is longer than the prep, but It doesn't actually say that. So that while for a fact, and especially in the spirit of Johnson's rule, that means that the baked apples would go first, I'm still going to kind of weaken it and say, well, yeah, it would probably go first. I mean, I'd have to see the rest of the numbers because I could possibly cook up a contrary scenario. But anyway, Johnson's rule, look for the smallest number. If it's at the first workstation, the first department, the first center, to the front. If it's at the second workstation, the second department, whatever, to the back. That's the key.